So this is part 2 of the foundational equation of Einstein's special relativity. So a general note I'll make is the term light speed, you've got to be aware of what it's supposed to mean in the context of special relativity. And that's how it's usually interpreted. And there's other types of light speed, sort of like local light speed, global light speed and all that sort of stuff, but just saying light speed, it's usually meant in the context of special relativity. Anyway, proceeding, I noticed this foundational equation for special relativity that relativity text seemed to miss out, and it's this equation shown here. Let's have a look. Yeah, I think I've written it properly. So it's c prime squared t prime squared is equal to open bracket c squared minus v squared close bracket t squared. And I decided to see what AI says about it, so I'm continuing on from what was happening in the last one in part 1. And so going by my favourite AI, which is ChatGPT, that collects information together which would otherwise be difficult to obtain. And I'm going to summarise now the sort of thing I did in part 1. Part 1 is about deriving the equation and so forth. Now I'm trying to explain what the equation means, and AI's hopefully going to make that clearer. So my question to AI was, what physics is based on t prime equal to t and c prime not equal to c, and what physics is based on t prime not equal to t and c prime equal to c in the equation I've just given you. And ChatGPT AI says, great question, you've actually put your finger on the deepest structural difference between Lorentzian stroke neo-Newtonian physics and Einsteinian relativity. Let's carefully parse it. And so this is why it's a foundational equation. It's showing the connection between Einstein and Newton from that equation. So AI takes up the case of, which is called case A, of considering what happens when t prime is equal to t and c prime doesn't equal to c. And the interpretation from that is you've got times absolute, the same in all frames, and the speed of light is not invariant, it changes with the state of motion through the ether. And the physics framework is the Lorentz ether theory in its original form before Einstein's 1905 reinterpretation. So what you got basically, when that foundational equation uses t prime equals to t and c prime doesn't equal to c, then what you basically got is the theory that was around before Einstein came along. And so, or it could be a modern neo-Lorentzian ether model where light speed depends on ether drift and synchronization convention. And so the consequence is all time dilation and length contraction effects are real dynamical effects caused by motion through the ether, not a matter of coordinate transformations. You can preserve a Galilean time, that is absolute time, but must give up invariance of c. So case B is when t prime doesn't equal to t and c prime is equal to c. And the interpretation for that is that time is relative. Clocks in the different frames tick at different rates. The speed of light is invariant and the same for all observers. So the physics framework is Einstein's special relativity, and that was later built into general relativity. Hence consequences are Lorentz transformations replace Galilean transformations, time dilation and relativity of simultaneity become kinematic, built into the coordinates, not caused by an underlying ether. And a lot of this is modern interpretation of special relativity, because if you go by what Einstein's writing in 1905, it's not quite clear what he's talking about, and we've had other people come along after him and try to tidy things up for special relativity. So AI continues. The equation you wrote, do I have to say, read it out? That's it written down. If we impose case A, which is absolute time, then the equation becomes shown there as that c prime squared is equal to c squared minus v squared, and the effect is light speed change with motion through the ether. And that's the equation it's going by. If we impose case B, which is invariant light speed, c prime is equal to c, and then we get this equation for the time dilation, and it's a familiar time dilation equation of special relativity. If you go to distance, some distance start complaining it's not an effect on time, it's just an effect on the clocks, how the clocks are measuring rates of time. The clocks are being affected and not an effect on time. But putting that issue aside, so AI says, so the same equation can be read in two opposite ways, and that's the equation I presented, the foundational equation. And the two ways it can be read is either, the first way is the Lorentzian, which is neo-Newtonian with absolute time and variable c, or the other way is Einsteinian, relativistic with special relativity, and you've got invariant c and relative time. And of course, experiments can be interpreted from both possibilities, but that's as far as I'm going in this little video. I've highlighted what the equation is talking about. It's shown the link between Newtonian physics and Einstein. So that's it.